Hi, and welcome to Geeks for Geeks. Today, we would be discussing yesterday's problem of the day, that is unequal arrays. So, before we move forward, let me give you a brief introduction about me. I'm Siddharth Hazra. I'm an SD at Geeks for Geeks. Beside that, I'm also a candidate master at Code Forces. So, in which year you are in, sir? So, currently, I'm in my fourth year of BTech. Okay, so I think we can start at this point of time. Let me just turn off this. Yep, good to go. Hi, Nakach. Okay, nowadays, so by the way, I was going through this, all the comments on this, and nowadays, people are participating very actively over this discuss section. The comments are getting pinned and it is getting a lot of votes and all. So this is a very new thing I'm observing, and kudos to you all. So yep, so now let us discuss this thing. So is my screen getting shared? Let me just see. Yep. Hi Yuvraj Verma. Okay, so fair enough. So in this question, we are given two arrays, that is A and B of length n, and both the length are equal. And now you can perform two tasks. Okay, the task is you can subtract 2 from one element and add 2 to the second element. It is just like this. Suppose I have, suppose the whole country has some denomination of notes. Like let's say that the whole country, like the India, the number of rupees is 100 in the whole India. So money is not getting produced, it just goes from one person to the next person. There is a big analogy. Okay, so the analogy is, suppose I have, let's say, 20 rupees and my friend has 30 rupees. So I can subtract 10 rupees from me and then I can give him 10 rupees to him. Okay, money never get produced, it just moves from one person to the next person. So in the same manner, here also we can't explicitly add or subtract any values. We subtract the value from one element and add that value to the next element, and that value is also fixed, which is 2. Okay, so it is just like subtract 2 from one element, add to the next element. This is the available operation that you can do. So the operation is subtract 2 and add 2, and this can only be done on array A, and you need to transform A to B, okay, to make array A and B equal. Now there is one more thing that is written. It is told that they are equal if the frequency of each element is equal in both of them. It doesn't mean that it is 1, 2, 3 and 3, 2, 1. So it is telling us that these two arrays would be considered as equal. Why? Because the frequency of 3 is same, the frequency of 2 is same, the frequency of 1 is same. So now I can say that instead of this equal term, I should use the term known as anagram to make A and B anagram of each other. What is the meaning of anagram? You can just go here and see this. So basically, anagram, just a sec. Yep, anagram GFG practice. So just go out and solve this question. So an anagram of a string, another string, contains the same character, only the character ordering can be different. So it is just telling us that it can be an anagram of each other. Don't just take it that it is equal. So the correct term would be that to make the modifications in the array A, so that after making the modification, array A would be an anagram of array B. Please remember this. Okay, don't consider this Let's say that they are just anagram of each other and it would be clear. So if we are talking about anagram, then yes, 1 to 3 is anagram of 3 to 1. Okay, and it is also equal. Okay, don't say it is equal. Don't use this term. Okay, so now we just need to modify A so that it becomes an anagram. So the given value is 2, 5, and 6. Okay, and this is 1, 2, and 10. Okay, so now what I can do is I can add 2 and then I can subtract 2 from here. I can again add 2 and then again I can subtract 2. This would convert this thing 2 to 2 only because it didn't do any modification. 5 minus 4 would make it 1. 6 would be transformed to 10. So now if you observe, 2, 1, 10 is an anagram of 1 to 10. So how many operation did we do? We did one operation, this one, and another operation, this one. So we did two operation, and by doing two operation, we got this thing. This is how this output is popping up. Okay. As the second sample test case does not have any solution, so we won't be talking in that direction. Okay. So am I clear with what is the question? Am I clear with the sample test case or not? Give me a quick one in the chat. Just give me a quick one. Am I clear with the sample test case and am I clear with the problem statement or not? Okay, we'll just move forward. Okay, thank you, Rashid. Okay, so now if you observe this, okay, if you observe this 256 and 252. So as I told this example, money is never getting produced, but it is going from one person to the next person. Okay. So here also we are subtracting to here and we are adding to here. We are subtracting to here. We are adding to here. So if the initial sum, let's say 1 to 3 is given, if the initial sum is x, then whatever operation we do, that is adding 1 and subtracting 1, still, in spite of how many operation we do, the sum would still be x. So let's say that we add here 2 and we subtract here 2. So that would be 3, 2, 1. And the sum is still 3 plus 2 plus 1, that is 6. And here also the sum is 6. And if we again do it, that is, let's say we subtract here 2 and we add here 2, then it would be again 3, 0, 3. And that would be again 6. So in spite of how many times we perform this operation, the sum that is getting produced would still be the same. So sum is not changing. Okay, in spite of how many operation. So let's say that the sum of array A1, let's say A1, A2, A3, A4, A5, dot, 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 it equals to the sum X. And let's say B1, B2, B3, B4, and B5 equals to the sum Y. Okay. So as you can see, we can't change the sum. But if a particular number is an anagram of each other, then the sum of both of them would be same. So if x is not equal to y, then I would say I can't perform this operation. Let's see an example of that. So the example would be, we have something like 3398. 3398. So the sum of this is 6 and the sum of this is 17. So we can never make this 6 go to 17. That is why we can say if the sum of both the array is not equal, then it is not possible. It's simple. So first I would say sum of A should be equal to sum of B. This is the very first condition we can move forward. And this is very easy. Like, just take the example that money is never getting produced, but it moves from one person to other person. Remember this example and you would be able to understand this. Now let's talk about the few more observation that we can draw. Okay. The difference between an even number and an even number is an even number, and the difference between an odd number and an odd number is also an even number. And let's say odd minus even, it is not equal to even, but it is equal to odd. Okay, like let's say 6 minus 3 is equals to 3, even minus odd. 10 minus 7 is equals to again 3. 10 minus 5 is equals to again 5. This is how you can verify. Okay, so we have this kind of relation. Okay, odd, odd, even, odd, odd, even. So now we can say that 2 is an even number. So we can only increment or decrement a value by an even number. Okay, like if we, like suppose the value is x and we want to convert it to y. Suppose the given value is x. Suppose we have a value x and we want to convert it to y. So we can only add even numbers to it, because 2 plus 2 plus 2 plus 2 4, 4 plus 2 6, 6 plus 2 8. Like let's say I have here, let's say I have here 4 and I want to convert it to 8. This is possible. How? I can just add 2 plus 2, and I can subtract minus 2 from somewhere else, and I can convert it to 8. 4 can be converted to 8 by doing this. Let's say I have something like I have an even number and I want to convert it to, let's say, 7. This is not possible. Why? Because we would add 2 and now we need 1, but 1 is not possible. So that is why an even number can never be transformed to an odd number. Why? Because we are having this relation, even number plus odd number is equals to never this. So if the given value is even, we need to pair it with an even value. It's simple. That even value should be paired with an even value, and odd value should be paired with an odd value. Like 6 can be converted to 10, and 3, okay, like let's say 11, 13 minus 11, yep, 11 to 13, the value is the difference between them is 2. Here also the difference between them is 4. Odd and odd, let's see some more examples. 5 and 9, so the difference between them is 4. So the difference between odd and odd is even, and even is also even. So even should be paired up with even, and odd should be paired up with odd. Okay, please remember this. So now we can say that the first condition was that the sum of A is equals to the sum of B. The sum of A is equals to sum of B. The very next one is frequency of even frequency of even in array A in A should be equal to frequency of even in B. And then the converse of it, that the frequency of odd in A is equal to frequency of odd in B itself. Okay, these are the two conditions that needs to be fulfilled. If these two conditions are fulfilled, then conversion is possible. Then conversion is possible. Remember this. Okay, this was the very first observation. So if the answer is -1, either of this condition would be false. Okay, now the question is, if it is not possible, we would return -1. Now the question is, how many operations are needed? how many operations are needed. If it is not possible, it is not true. So what we can do is we can first check all these conditions. Okay, we can check all these conditions and that would be easy to do. Okay, so first let us just solve for all this condition. Mhm. Like let's just solve this for all. I'm a very lazy person, would make this as A, would make this as B, and would have it as N. Let's remove this. I was solving this on my own. So that I didn't have a pen and paper today. That is why. So now what we can do is we would just save all the values. Okay. So I would say the index 0 would store me the odd values and the index 1 would store me the even values. Okay. Now I would make two arrays, vector int a, vector int array odd even a, okay, of size 2 and odd even b of size 2. Okay, it is a vector of arrays, so we can push element at both. So here instead of just counting, we are just pushing, and I would tell you at the end what is the use of that. So instead of just counting, we are saving what are the even values in A, what are the even values in B, what are the odd values in A, what are the odd values in B. Here we are just saving. Okay. And we would also have a sum variable. So long, as we know that the sum would be very long by this only. Or you can just observe the constraint 10 to the power 10 to the power 5 multiplied with 10 to the power 9 is more than 10 to the power 9. So we require data type greater than integer. So I can do this. So this is sum of A is equals to 0 and sum of B is equals to 0. Now what we would do is we would start the iteration. For int I is equals to 0, I is less than n, and I plus plus. Now I would say that first sum of A plus is equals to A of I, and sum of B plus is equals to B of I. First I would add up these two values. We have the sum. Now we would check if A of I modulo 2 is equals to 0. This just tells us that it is an even value. If it is an even value, then what we need to do? We would insert it in one of even. Okay. Or let's just swap it 0.0 even and 1 odd. Okay. Even odd. Okay. So what we would do is we would say A O E A. Okay, and it is an even value, so we would insert at index 0 OEA 0 comma push back the value of A of I. Okay, if it is not a even value, then it is an odd value. Simple enough. And this time we would push it. So if it is an odd value, we would save it at the first index. So this would be OEA comma A of I. Now we would just copy the conditions of this only, and we would just change the array. If B of I modulo 2 is equals to 0, then OEB dot push back B of I, else OEB dot push back B of I. And this is done. Okay. So the first condition was that if sum of A is not equal to sum of B, or the number of odd is not equal to even, or number of even is not, like the number of even in both is equal, or odd is equal in both. Okay, like we can check both the things, like say We can check both the condition, or we can check only one condition also, because there exist only two types of element, so we can only check for one type. So suppose there are 26 boys and 36 girls. Okay, so if we just so if the class contains only boys and girls, then we can just count the number of boys in the next class, and we know that the remaining one would be the girls, because there are only two types of genders. So in the same manner, we can just, as there only exist even and odd, so at this point we would say OEA dot zero dot size, okay, if it is not equal to the same corresponding in OAB dot size. Okay, if this is the condition, then we would return -1 at this point. Simple enough. Now, this is done. It is suppose it is not possible, then -1 is returned. So not possible ka case we have handled. Now comes the question: count the number of operation. Count the number of operation required. This is what you need to do. Or let me just write it a little bit. My handwriting is absolutely very bad. Count the number of operations. Now this is our goal. Okay. How to solve this thing? Now we want to count the number of operation, how we can achieve that. So to do that, let us just analyze the given test case. What was that given? 256 1 to 10. 256 1 to 10. 256 1 to 10. 2 5 6 and 1 to 10. So as I told, that even number should be coupled with even number and odd number should be coupled with odd number. So what I would do is I would take up this 5, keep it here. I would couple up with this and I would couple up with this. Okay. So now here the difference is 4. Here the difference is 0. Here the difference is 4. Okay. So we require a total of 8 value. Okay, we require a total of 8 changes. Okay, like to make 1 go to 5, we require -4 and this. So 4 plus 4 is equals to 8. So we need a change of 8. So in one change, +2 -2. In one change, I can make an impact of 4. In one change, I make an impact of 4. So I can say 8 divided by 2 divided by 2, which is equals to 2. So if I make an impact of 4 in one operation, then to make an impact of 8, I would require 2 operation. So now I would just calculate the sum of the modification we require, divide it by 2 or 4 accordingly, and then we would be good to go. Just this. Okay. So now what we can do is, am I presenting my screen? Okay. So now at this point, long answer is equals to 0. Okay. And then I would just iterate over for int I is equals to 0, I is less than 2. And someone asked me a query and I would reply that please just wait for some time. So now I would just iterate over odd and even. 0 and 1. 0 and 1 is odd and even. See, 0 and 1 is odd and even. So now let me just take up this one and just write it here. Okay, now you would understand better. So first we would sort the values. Why are we sorting the values? This is very important. So let's say that if I had kept this 2 here and this 6 here, then I would have required a change of 4 here and a change of 8 here. So smaller element should be also coupled with smaller element so that the amount of change required is less. Okay. So a smaller element should be coupled with a smaller element so the absolute difference between them is less. This is the reason. 6 and 2, 2 and 10. This is more. But if we just go back, okay, if we just go back to whatever was already there, if we just couple up 2 with the smaller value with a smaller value and larger value with a larger value, then it is there. So there are two conditions on which we need to pair up. The conditions are pair odd with odd and even with even. And the next is that pair small with small only. So like let's say suppose we have 1 2 3. Okay, why I'm like, let's say I have 1 2 3 4 5 and this is 5 4 3 2 1. Now let's say the question is asking me that rearrange the elements of the second array so that the absolute difference between the corresponding element is less. So what you would do is you would simply sort up this array. Why? Because then the absolute difference between the corresponding element is very less. That is why we would be sorting both the values so that the small value is coupled with a small value, second small value is a second large value is a coupled with second large value, third large value is third large value. So the absolute difference between them is less. That is why we are sorting that. So sort a of 0 dot begin comma a dot 0 dot end sorted out. So this is even of a. This is even of a. 0 is what? 0 is even. Now odd of a needs to be also sorted, which is just 1 1, and this is odd of a. In the same manner, we need to do it for b. Mhm. Do it for b, b, and then we don't require this loop. Okay, everything is done. Don't require this loop. Like this loop would have confused some people. That is why I completely removed the loop. I'm sorting all the even numbers of a, all the even number, all the odd of a. I'm sorting all the odd of a, then even of b, then odd of b. I'm just sorting both of them. After sorting it, I would just add the absolute difference divided by it. Okay. So what I would do is for int j is equals to 0, j is less than now for int I is equals to 0, I is less than 2 and I plus plus. Okay. Now we would just iterate over the all the even values, absolute difference, even values, absolute difference. So now I would say that for all the values for int j is equals to 0, j is less than equal to, j is less than equal to odd even, k dot I dot size and j plus plus. Okay, so now I would say answer plus is equals to abs of odd even, a dash I dash j minus odd even b dash I dash j. Yep. Then divided by, so let's just have it here. Then just return answer by 4. Answer by 4. And it would be the same. Okay. So first a of I and j. So first I would be equal to 0. So 0 minus 0 of I and j, 0 of I and j, 0 of I and j, then 1 of I and j. Okay. So now even of a, smallest even of a, smallest even, like let's say after this thing we would have something like this. So it would be like this: 2 and 6, 2 and 10. First we are doing the difference, added to 2, difference added to, so this would give me 4. Then here we would have 1 and 5. So it would also give me 4. So 4 plus 4 divided by 4 would give me 2. Okay, now let us just compile and run and see how many errors are we making. Okay. Okay. I was a little bit suspect, I didn't trust my solution so much. Why? Because this uses a lot of numbers and all. Okay, so this is the whole code. I would present, so I would copy up this one, give you this. Copy to clipboard, done. Then paste it, then generate the URL. Copy, paste. Now you can just see the screen. Chrome tab unequal. Yep. So now you can just see up this one. And if you have any issues, you can ask me. I would be waiting for the next 30 seconds. Can you please name some of the algos or techniques which are not so common but are important, like line sweep, middle in the middle, binary lifting, and then there are other underdog algorithms too. Like there are many underdog algorithms that you need to learn. To be honest, if Yuvraj Verma, are you still there? If you're still there, I can quickly tell you. Sir, how do you swap 2 and 5? Do you need to sort the even and odd arrays? Yes, we need to sort the even and odd arrays so that the absolute difference between them is less. Any issues? Sir, can you name please? So the very first one is like some important algorithms. Making up the recursion tree is very important, which is an underdog thing, but it is important. Then cadence algorithm, then prefix sum mixed up with map, then modification of unordered map so that it works on an average of big of 1. Okay, so got it sort. Okay, thank you. So that's it for today. So if you're watching this stream in the recorded version, feel free to like and comment on the video so that the reach of this video could be increased. Yuvraj Verma, just drop a comment over this video and I would reply all the algorithms that are important at the bottom. That's it for today. Thank you everyone.